Our social structures and employment conditions are significantly and rapidly changing, with trends such as an aging society and the decline in the working age population increasing globalization and technological innovations. Facing dynamic social upheavals such as these, we are now unable to foresee even our immediate future. Under such conditions, our students are asked to proactively face these changes, identifying and resolving various issues, to collect information from a variety of sources, figure out how to use it to create new value, and to act purposefully in complex situations that constantly evolve. Specifically, when students face various obstacles in their everyday lives, they must follow these steps. Define the problem. Identify a method or methods to solve the problem. Devise and implement a solution. In other words, they have to cultivate problem-solving skills. The OECD published a report on collaborative problem-solving as part of their PISA 2015 results, where Japan ranked first among 32 participating countries. In this report, OECD defines collaborative problem-solving competency as the capacity of an individual to effectively engage in a process whereby two or more agents attempt to solve a problem by sharing the understanding and effort required to come to a solution, and pooling their knowledge, skills, and efforts to reach that solution. As the country that ranked highest in collaborative problem-solving, we believe that it is important for us to share our teaching strategies for developing this competency with our students. When we hear the term problem-solving, we often imagine two types of problem. One is an issue that requires deliberation and research for finding a solution. The other is an obstacle needing a solution, and this can refer to the goals implicit in the methods that lead to the solution of a problem. We will not differentiate between these two in our approach to problem-solving skills. For our purposes, we will define problem-solving competency as the ability to identify one's own issues and those shared by the group to which one belongs, which need to be clarified, known, improved, and/or resolved, as well as the ability to achieve these solutions and goals. In students' everyday lives and at school, problem-solving may include aspiring to improve one's life, finding issues that prevent one from improving one's life, setting specific goals to solve these issues, devising a solution by engaging with the issues from multiple perspectives, implementing the solution. Upon encountering failure, revising the solution anew. Based on this understanding, Tokyo Gakuge University professors specializing in subject pedagogy analyzed subject lessons where students solved problems they faced so as to identify common elements. These have been compiled as lesson strategies to cultivate problem-solving skills. 6 strategies were found for cultivating problem-solving skills. We will explain each using examples from a variety of subject lessons. We will use videos of actual lessons to illustrate strategies 1 through 5. The first strategy is to clarify student goals. Regardless of the subject, it is imperative for students to clarify their learning goals. What kind of problems do I need to solve in order to reach my goals? What kind of paths are available to reach my goals? We believe that for students, setting goals and then planning the path to achieving these goals is the first step in their learning process. Depending on what is to be learned, students may set their goals under the guidance of their teachers, or they may do so on their own, exploratively. Either way, it is important that their goals be clarified. In this next video from a second-year junior high school science class, the teacher introduces a lesson topic on the regularity of mass for objects under chemical reaction. By sharing their observations of changes to the mass, the students try to find a solution to the problem that the teacher raised in the beginning.
いろんなことを書いてくれた人がいたんですが、大体みんな機体の出入りに注目してくれてるんですね。もう一個ね、プラスアルファちょっと書いてくれたのがあって、いいこれ。そういうことなんだけど、これもいいなと思ったからさ、ちょっとそのまま読むね。複数の物質がただ加工しただけなら、質量は変わらず、気体と結びついたり離れたりしたら質量が変化する。この辺みんな多くの人気づいてましたね。で、プラスしてね、こんなこと書いてきました。空気中と何かと結びついたり離れたりしているので、空気中を含める全域で考えたら質量は変わってないんじゃないかとかっていうところまでちょっと思いが至って聞いてることがありました。他にも何人かねそういうことを書いてくれる人いるんですが、つまり全部含めて考えちゃえば変わらないんじゃないかっていうことにちょっと気になってるっていうのが出るけどね。なので今日のテーマとしては一応全部測ってみたいな。要するに出入りした気体も全部含めて測っちゃえば変わらないんじゃないかってことを確かめられるんだったら確かめてみたいなというふうに思うんですね。簡単なアイデアで
スチールが吸収する酸素の部分を覆ってで密閉した状態でやればなんか変わらないんじゃないかって皆さんなっちゃうんです。どういうこと？スチールって周りから酸素を取るから重くなるんだ。その周りを囲んでなんか密閉した状態で燃やしてでそうさ空気も一緒に入れて状態で重さを測ってみる。なるほど。じゃあ瓶などに入れてやるってことですか？
What did you think? We hope the video helped you understand how, when goals are clarified, discussions can be had as a group as to how to best arrive at these goals. The second strategy is to create situations where students seek solutions and improvements. In order to solve problems in class, we often have students discuss how to arrive at solutions through group work. It is important that we guide these discussions by helping students think in the following manner. I want to solve the problem responsibly. I want to solve the problem because it's related to my everyday life. I want to know how I can contribute to solving the problem. Moreover, it is important for us to help students recognize that problem solving is a process. Students might think, I solved the problem, but I encountered a new problem. This is to be expected, and teachers can then help students understand the significance of recognizing or identifying the new problem. In the next video, from a first-year junior high school physical education class, students discuss how to strategize as a team to raise their score in the context of a soft volleyball game.
3人でやるんですけども、1人がトスを上げる人で2人余ってて、前までは1人しか打つところに動かなかったんですけど、2人動くことによってどっちにそのトスのボールが上がるかが読めなくなってくるから、それでその相手が来た方の逆の方に上げて決めるっていうことをしようっていう話をしてます。
This video showed how students discussed their roles with the objective of winning a match. We saw how the students demonstrated their desire to solve and improve while they discussed their strategies for winning, which is an important attitude to have for solving problems.
問題解決に必要な姿勢を引き出している授業だったと言えます。
The third strategy is to create a safe space to work on a trial and error basis. In a classroom setting, when students define their goal and work on the problem with an attitude of wanting to solve and improve, they will inevitably work on a trial and error basis through discussions or activities. The trial and error may naturally arise from the student's search for a solution, or the teacher may intentionally introduce this as a class activity. The teacher can do the following: provide a framework so the students can imagine how to solve the problem. Set up the classroom so students can experiment with ideas and objects. Have students review their methods for solving the problem. As the last point suggests, facilitation includes an intervention where students are made to stop and reflect on their approach to the problem. In the next video, third-year junior high school students are making a lampshade for an LED light fixture to be used for the hydroponic cultivation of lettuce. This lesson in technology, sometimes called industrial arts, involves the fabrication of materials. We will see how the students are working on a trial and error basis.
いいっすよ。で、曲がる曲がる、もう曲がる。さあ、どうぞと映るんだよ、つまり。俺曲がる。お、すげえ。すげえ。曲がってきてる、これ。いい？上げて、上げて、こう曲げる。どうやってやるんですか？よし、曲がった曲がった曲がった。それをこう何回も繰り返して。
プラスチックの加工そのものが初めてという生徒がほぼ多数です。趣味で何かを作っているとかいう子を除けば、プラスチックの基本的な加工、穴を開けるとか、曲げるとか。ということはほとんどの生徒が初めてですから私もあまり見本を示さないで自分たちで考えてやってみるやけどとか安全には配慮しながらもちろんやるわけですけれどもでなんて言ったらいいのかしら加熱して曲げるっていう事象を見て初めて子どもたちがプラスチックってこんなに簡単に加工ができるんだこれみんなでなんだろうな知ればもっといろんな作業ができるんじゃないかっていうきっかけにはしたいなというふうなつもりはあるんです。
This video showed how students work together on a trial and error basis. While they voiced their understanding as, wow, and this is how you're supposed to do it, we can surmise that their understanding was prompted by inquiries such as, how do I bend plastic? How do I use this machine? Or what do I need to do to get it right? As the teacher says in his comments, we believe it's important to keep instruction to a minimum so students can explore and discover what they can do on their own. The fourth strategy is to encourage students to study with others. As we've seen in the previous videos, it's important for students to discuss and work together with others, such as friends and classmates. When students work as a group, it is important that they recognize the opinions and ideas of others by considering, people have different opinions. I wonder which opinion is correct. Acquire new knowledge and methods that spark the excitement of discovery, as in, it never occurred to me to use that method. Moreover, students might deepen their discussion by engaging in friendly competition with others, saying, the other team came up with a new strategy. The next video is from a first-year junior high school science experiment in which students identified different types of plastic. The students acquire both knowledge of the chemical properties of plastics and the skills to apply when examining changes made to their properties. Here, they devise their own experimentation plan. As we saw, the students recognized that the others had different opinions. Then they deliberated on the most appropriate methods to use based on these opinions shared by the group. The fifth strategy is to prepare visualization tools. When solving problems, it's useful to have a visual grasp of others' ideas as well as one's own in order to confirm them and overcome obstacles during discussions and tasks. In other words, a visualization tool can make it easier for students to identify the problem, confirm whether an experiment worked. It can also help students recognize the variety of ways to see and think about a topic. In the next video, second-year junior high school students apply mathematics to a social issue in a unit titled, "Let's Increase the Number of Lives That Can Be Saved Using AEDs." In this lesson, students are introduced to a variety of data sets to inquire whether AEDs are installed at appropriate distances from each other in the neighborhood. The video shows a student explaining the areas that are covered by each AED shown on a neighborhood map projected onto the blackboard.
その後、この300メートルの位置を消し取って、その AED があるところから300メートルを中心とした半径3、この地図上でいうと半径300メートルの円の円というか方を書いていって。とりあえず今これ3つだけなんですけど、この3つだ、少なくともこの AD3 つで
色がある、
これだけの地域が半径300メートル以内に含まれているっていうのが分かりました。でこれを全ての AED でやって、どのぐらいまでこの AED で助ける、その3分以内に助けることができるかを調べました、
ね、AED を中心に円を書いていきました。で今この1つ2つ3つについて円を書いてる状態です。いいですか？さあ同じ方法だった人、同じ方法かな、はい、同じ方法何人かいました。でじゃあこのことから300メートル、右側に設置されている AED は300メートルごとにあると言えるかな。どうですか？言える？言えた？分かった。はいはい、なるほど。
By drawing her answer on the blackboard, this student was able to share her thoughts with the class and help solve the problem that was presented in the lesson. The sixth and final strategy is to introduce a topic that must be deliberated from diverse standpoints. When students engage in a discussion, they may end up thinking about a problem from a single viewpoint, resulting in a biased understanding. Say, for example, that students are challenged to improve the function of an object. An easy solution is to apply the latest technology to make the improvement. However, this solution does not take cost into consideration. Applying the latest technology can be costly. In addition to cost, there may be other factors such as environmental consequences and time management that need to be considered. In many cases, students must reach an appropriate solution by deliberating the multiple facets of a problem from a variety of perspectives. At the same time, students must prioritize their goal so that they are able to sort out what is essential from the vast amount of miscellaneous information. We will use an example from a junior high school science class to explain this point. In the process of solving a problem, it is difficult to arrive at a solution by sticking to a single approach. For example, in junior high school science curricula, it's considered important that students be able to choose the most appropriate solution when faced with a trade-off between scientific technology and environmental sustainability by examining the problematic from a variety of standpoints. Similarly, in other subjects, students are asked to think about a problem not only from the position of a Japanese person, but also non-Japanese persons, or not only from a consumer's position, but also from a retailer's or manufacturer's position. In this way, we believe that it is important to introduce topics and materials that allow students to deliberate from a variety of positions. We've introduced the following 6 strategies to cultivate problem-solving skills using examples from 4 junior high school subject lessons. Clarify students' goals. Create situations where students seek solutions and improvements. Create a safe space to work on a trial and error basis. Encourage students to study with others. Prepare visualization tools. Introduce a topic that must be deliberated from diverse standpoints. These 6 strategies can easily be incorporated into subject lessons, as some teachers may already be doing. What's important is that teachers make use of these 6 strategies while helping students experience the problem-solving process through practice, so they may conceptualize the problem-solving process. Doing so will encourage students to acquire problem-solving skills.